Okay, 7-4, similar right triangles. Similar right triangles. How can I figure out what is it WY?
Yes.
What is WY? What is WY? Round to the nearest tenth.
So,
How can I figure that out?
XV is the hypotenuse of the large triangle.
XV is the hypotenuse of the large triangle,
Yes,
okay?
and XY is the hypotenuse of the smaller triangle.
Okay,
So you can put those, like, they're like,
I think that
in a
XY
proportion.
and you can put them into a proportion, okay? And you can figure some stuff out from there.
So then you know that,
So
Well-
can we draw those real quick so that I can see
yes.
them? Okay. So the large triangle, right now, the right angle is like this,
Oh, that's what you said.
right here, and this is Y, correct?
Mhm.
X, and this is V. 13, 5, 12, right?
Yes.
And which one do you want me to compare it to? Because we're trying to find
We're trying to find
WY.
WY, which is, I don't know the word,
A squared plus B squared equals
But-
C squared.
it's 2.
So smart, Brandon.
W,
Or you could just do 12
Mhm.
squared
Abby,
plus b
where-
squared equals 13
Look, give me
squared.
that, look.
That makes
Literally
more sense to me,
figured it
but
out.
that's just me.
In one line.
No, it's 5.
Oh, yeah, I get that. Well, it has to be right, it has to be right.
It's the,
Right
oh,
triangle.
it is a right triangle.
Oh, yes, they can do.
It is a right triangle.
time out, you might be looking at a different triangle than I'm looking at.
I'm looking at XWY.
Do I have an X up on that, on this triangle?
Oh, is that the one we're looking at?
I don't know, that's what I'm
Wow,
trying to
Ollie.
decide.
I was thinking since the smaller, the little triangle, XWY, I thought we could do that one.
Okay, XWY,
Yes, because you know
Which would
the
make-
hypotenuse is 5.
this W
Yeah.
makes
W.
this X and this Y,
Yeah.
See,
and then this is 5,
Yep.
Mm-hmm.
okay?
And then YW is 2YB.
So like
Right.
you
What?
do 13 over,
Can we just
5
do
over
A squared plus
13
B
is
squared
2
equals
5
C
over X.
squared?
Yeah.
for now.
Like,
Time out.
can we stop this?
can we just,
What did you say? Repeat.
5 over 13.
5 over 13, because you're trying to figure out what
YW is.
oh, I see why we
this
can't
is
do
here.
that.
Yeah.
So you wanna know what this is.
X.
Okay, so you're saying, let's compare this to this.
And then question mark to 12
5 over 13 equals this over 12, yes?
is what I'm saying.
Okay, so then you get 60 equals whatever, like that?
Yeah.
So then what's 60 divided by 13?
It's like 4 something, 4.5.
Isn't it 13?
It's like,
It's 4 something.
No, it's not.
It
It's
can't.
I think it's
35.
4 and a
Oh,
half.
yeah, sorry, my bad.
It's like 4 something.
4.5.
And it said round to, so 4.6?
Boom.
What'd you say, Karen?
Yes.
What's
Okay.
close enough?
So do you see why I break it down? Did you see how there are 3 options there? Okay, because I could have done it this way too, right, with this?
Yeah.
Because I could have used that 12 and 13 and X and 5 like that instead.
Yeah.
So it depends how you see things, correct?
Mm-hmm.
Okay, so show me your work. Converse of the Pythagorean theorem. If the sides of a triangle have the lengths A, B, and C that satisfy A squared plus B squared equals C squared, then the triangle is a right triangle.
Wow.
The converse. So if A squared plus B squared equals C squared, then ABC is a right triangle. Cool?
Nice.
Wait, so it's literally.
Like I should believe.
It's, but it's saying, we usually use Pythagorean theorem to prove, or we know it's a right triangle, so we use the theorem to figure out portions of it.
You already
This
know
is-
the measurements, you're figuring out if it's the right triangle.
Right,
Okay.
Wait, Pythagorean theorem has to be a right triangle?
Yeah.
yes,
Yeah.
Okay.
I did not know that.
okay?
So,
So, usually we know it's a right triangle, so we use Pythagorean theorem to find side lengths. Now, they're saying, tell me if this is a right triangle, so I'm using Pythagorean theorem to prove if it's a right triangle or not.
Okay.
Make sense? That's why it's the converse. Okay? Which means I can use the Pythagorean theorem to decide if it's a right triangle, if it's obtuse, or if it's an acute triangle. We'll get to that in a minute.
Darn.
Converse of Pythagorean theorem. A triangle has the sides 2, 3, and radical 13. Is it a right triangle?
I
Triangle
know.
13, let's find out.
Yes.
You do 13 times 13 and then
You just square both of them and it has equal.
No.
3.6.
Oh, yeah.
Okay, so radical 13 would be what, my A, B, or my C?
Your C, because it's.
So I should say 2 squared plus 3 squared equals radical 13 squared. What's 2 squared?
4
Wow.
9. And equals 13.
Because these cancel.
Yeah, so yeah.
But listen, you have to show me this work.
I know you're looking right at me.
Only because you said dang it as soon as I said it. Okay? You have to show me the work, because you have to use the converse to prove it.
I got 86.
Okay, so here's the deal. If it's a right triangle, C squared equals A squared plus B squared. If it is an acute triangle, C squared is less than A squared plus B squared. So if it's acute, it's less than, that makes sense, right? Because it has to be smaller than a 90-degree angle. Okay, and if it's obtuse, that means that C squared is greater than A squared plus B squared. So anytime they give you 3 numbers to a triangle, 3 side lengths, you can tell me which of the 3 it is.
I love that.
And they're
Oh,
gonna start
wow.
to ask you to do it that way.
No, that's nice.
Does that make sense?
At least I don't have to do any extra stuff.
You don't have to do any of the extra stuff. No.
You're just lazy.
You just have to show me that work. That's why I need you to show me the work. Because if it doesn't come out to equal, I need to know, is it acute or obtuse?
I'm not lazy. I just
Cool.
don't like to do extra
Cool.
stuff.
Okay, so if
I
it's
hear
less
you.
than,
You're
if
lazy
C
too.
squared is less than the other 2 combined, it's acute. If C squared is greater than the other 2 combined, it's obtuse.
Yes,
Okay?
I'm silly now.
And that is the first lesson.
Oh boy. We're
That's-
supposed to say thanks.
You another
I mean,
one?
that wasn't
Can I have
that
it
long.
back? So
Now, let's talk second lesson. There are special types of right triangles for 7-5. Okay, there are 2 types we're gonna focus on, especially with trigonometry, and I'm telling you, in pre-calc, you're gonna come to love 45, 45, 90, and 30, 60, 90 triangles, because
I
there's a chart
do.
to memorize for them.
My mom hated
And if you
trig.
have the chart memorized, it makes life easier. Where you don't, life gets
Isn't
harder.
there a 44, 46, 90, and a
aren't you a 44?
That's nasty.
47?
Don't ever talk to me about that again.
Okay, so 45, 45, 90, 30,
89
60,
at
90, they have some special characteristics to them. Let's talk about those.
No, have you heard that TikTok?
Guys,
We're
focus,
getting hurt.
Where's Kurt guy?
focus, focus, focus. If I have a 45, 45, 90 triangle, it looks something like this.
Yes.
The hypotenuse is radical 2, and this is 1 and 1. Meaning,
Oh, it's a right triangle.
okay, the sides in comparison, the 2 sides that connect to make the right angle are going to be the same length,
Wow.
okay? The hypotenuse is going to be radical 2 times that length,
Wow.
radical 2 of that length.
Sorry, can you, okay, so 45, let me just reiterate. So
Be cool.
45, 45, 90 triangle.
Yes.
The 2 sides that connect with the right angle will be the same. And then that one will be, so this is just basic.
Right, because watch this. If I add a squared plus b squared to c squared here, yes?
Yard?
What's 1 squared plus 1 squared?
2.
And what is the square root of 2 squared?
2.
It's a 45, 45, 90. So so if I know what the length of this side is, let's say it's 6. What's the length of the hypotenuse then?
36. Radical 36.
What's 2 times 6 is
Radical?
12, and so then it'd be radical 12.
When did we just say?
Yeah.
Radical
Is it
6.
not radical 12?
That'd be 2.
Radical 6.
Oh,
Two.
because that,
Wait.
Okay, let's try something.
What's 36?
What is 6 squared plus 6
72.
squared?
72.
36 plus 36,
Yeah.
which would equal
72.
72, but
Radical.
it would be the square root of 72.
I
Time
figured that
out,
one out.
time out, time out, time out. I want to show you something.
4.
Break 72 down into a factor tree for me, what do you get?
36 and 2.
36 and 2. And what's 36 break down into? 6 and 6, so you get 6 radical 2.
That's
If the sides are 6, the hypotenuse is,
6 radical 2.
if the side is 7, the hypotenuse is,
7 radical 2.
if the hypotenuse is 9 radical 2, a side is
9
Nine
radical
radical
2.
Right.
Oh, that is 7.
45, 45, 90 triangles.
Wait, what?
Oh,
Coincidence? I think not.
You multiply the hypotenuse is radical 2 times the side. And the side is divided by radical 2 of the hypotenuse.
Thank you, Jesus.
45, 45, 90s have special patterns to them.
special powers.
Oh, it's got like.
Okay, and the reason is this. Remember how we talked about when our angles are marked, that the sides opposite them tell you what length each thing is? So if these are both 45, that
Oh,
makes
that
sense
was
that those sides are 1 and 1. And it makes sense that the other side is radical 2 times
Because
it.
of the,
Yes.
Dorothy's
Hypotenuse.
What's that long?
This is a dangerous
Okay.
position.
So now, let's look at a 30, 60, 90 triangle. Let's make that 90. Okay, and let's make,
The one on the bottom right. 60.
let's make the top 30 and the bottom 60.
Yes!
Okay,
I was
30,
right.
60. Okay, there's a special pattern to these. What do you notice about all those angles first off?
They're none of them are equal.
Okay, they're not the
Scaling.
same, but what else do you notice about them?
Scaling.
They're all multiple.
Listen to this, they are 30, 60, 90.
Plus 30.
They're multiples of each other, they
Yes.
go up, okay?
I
Wow.
said that.
So here's the deal on a 30, 60, 90 triangle. Whatever is between your 60 degrees and your 90, okay?
Yeah.
Let's pretend this is 1.
Okay.
Okay, or X or whatever, okay, 1. That would make your height radical 3 times the base, and that makes this 2 times the base.
Oh, we did this.
Did we?
Now that's awesome.
So a 30, 60, 90 triangle looks like that, meaning, okay, I have 1 squared, right, plus radical 3 squared, correct, equals 2 squared, right?
Y'all don't remember?
Okay, what's 1 squared?
1.
What's radical 3 squared?
3.
1 plus 3?
4.
And 2 squared
Oh
is?
my god.
4.
Whoa.
30, 60, 90.
Wow.
That.
So if you know 1, you can work backwards off of it. Here's the easiest way to work backwards. If I know this base, it's real simple because the hypotenuse is times 2 it, and the height is radical 3 times it. So if this is 6, that's 12. If this is 6, this is 6 radical 3.
That is.
Wow.
Okay? If I know this, let's say this is 7 radical 3, this becomes what?
7.
7, which makes that
14.
I think it's easier to work backwards that way.
Okay,
That makes
question
sense?
on.
If this is 24,
The other one's 12.
this is 12,
12
12
radical
radical
3.
3.
I am so.
Okay? So we now have special triangles to work with. Chloe, you got a question?
I just had it and then I forgot it. So
Okay.
I got it.
Okay, so what type of special triangle is this?
Oh, I remember it now. I'll forget it again.
Okay.
So when you do the radical 3 right there, if you,
I know what it is.
If you multiply it, do you multiply it to the other number too or no? Like, do you, like if it was 2 times radical 3, would it be 4?
Call on me,
4
call
times
on me.
3.
Oh, you mean if you put it, if you're squaring it like this?
Yeah.
Like if it says this?
If it's like,
Yes. How do you do that?
I would, you can do one of 2 ways. You can move the 4 back in here, which means you multiply 3 by 16, because you have 2 4, or by 16. Or, yes, you square this and then cancel that out.
And
It's
then you
gonna give
multiply them
this
together.
thing.
That's just how I do it. That's easier.
16 times 3?
Mhm.
Yes.
Okay, so what are the lengths of this triangle?
So wait.
It's a 40, 45, 91.
It's a 45, 49, 5, 90.
Yeah.
We have 6.
Because
So you have
Brandon
6
is a
each.
smart
You have
one.
6 each,
Yeah.
okay?
Yeah.
The leg opposite of the 60-degree angle of a 30-69 triangle has the length of 11 radical 3. What's the length of the hypotenuse? So the length opposite of the 60-degree angle, 11 radical 3.
6.
No,
What? I mean, that's what I meant. I meant
11.
22 radical 3.
11.
that's 22, good, and that's 11.
Yeah.
No, no radical 3. The only thing that's
There's radical 3 at the bottom.
no, it's
Oh.
not. You've got to read what the triangle looks like.
The leg opposite 60 is the base.
No, it's not.
I
The
totally
base
forgot.
doesn't mean, the base of a triangle doesn't mean it's what's laying flat on the ground. This is still the height of my
Oh,
triangle.
30 is at the top. Only
I never even
my
heard the
bad.
answer to the last one.
Okay, it is 90 feet from home plate to first base, and the same distance between any two bases. How far does a catcher have to throw from home plate to second base to the nearest foot? And I want the math behind it, boys that know the
120 feet.
answer.
45, 44, 90.
Yeah.
Is it 45, 45, 90?
Yeah,
Yeah.
that's the
No,
truth.
yes it is, of course it is.
Yes, it is.
Yeah.
Yeah.
Right,
Yeah.
okay.
Well, if you think
90
about
radical
it.
2 is the answer.
90 radical 2 is the answer.
I just
So what is that? Round 2 decimal places for me.
Something?
Well, put it in your
I shall
calculator.
answer it with my calculator.
That's 90 times radical 2.
12.
Wait, let me do this. It's 127.2792206.
Close enough.
0.28, okay.
Yeah.
Yeah, so those are the two things that you are going to work on.
So she said 90
Oh.
times
Oh.
square root of 2.
Dope!
Those are both
Wait,
lessons.
what was my?
127 point.
Did
you bring it back?
90 times radical 2.
Radical 2.
Don't even need to.
Yeah.
Yes.
Wait, so you take 90 radical 2 and then that?